Okay, so hello everybody to my talk about continuous integration from scratch. Mostly I will talk about a project we are doing right now where we want to provide continuous integration for our business unit in MSG, more or less out of the box. And I will talk about the conclusions we drew and are still drawing from that project. And about half the talk is about those conclusions, especially how to get a team that has not encountered continuous integration so far, AKA, ABAP, our free team, and how to get them to this continuous integration. Okay. I think it was just the laptop getting into sleep mode. Yeah. So about me, my name is Otmar Jatsch. I'm coming from Passau, Germany. I'm an employee from the MSG group, and I work for the technical guidance team. And the technical guidance team will occupy this room throughout the day. So Victor will be next. He will have a great talk about ABAP continuous integration, and then Helmut in the afternoon will talk about microservices. So stay tuned in room Ferdinand. So enough with the advertisement. Just my background. I'm by default a non-SAP developer. So I get into contact with SAP technologies, obviously, because I work for MSG, but most of the time I have no connections to SAP. And in the project that I'm working most of the time, or since 7 years, it is like this. I'm working with continuous integration, so there should be some background that I can give you. Okay, so very brief introduction about continuous integration. What is it for someone who does not exactly know what it is? So continuous integration is when you have a team, 2+ developers on that team that frequently commit some code, and you want to make it certain that if they commit their code, that your software is still running. So the workflow is a developer commits his code to a repository. That repository initiates a continuous integration tool which runs some tests against the new code integrated into the old code. Those tests can be building the software, if that still works, running different test sets from unit tests to integration tests to end-to-end tests, checking the software quality and the quality gates the team has made for themselves, something like test coverage, and deployment, if this software can still be deployed somewhere. And if everything is good, that's perfect, and that's the case most of the time, but if it's not good, it reports back to the developer to tell him that he has committed something that broke the build, and he has to fix his code. So that's continuous integration in a nutshell. And why do we want to do continuous integration? So I looked at the 2017 State of DevOps report, and I just will go into detail on 2 of the numbers here. On the right upper, you see that the failure rate, if you're doing continuous integration and continuous development, will go down by about 80%. So you will have 4 out of 5 defects that you normally have in your software, you will not have in your software. That's what they try to tell us with that. And let's look at this number. The change lead time goes down drastically. So change lead time means the time from starting a feature until that feature goes live. And if you don't have continuous integration, or in the old product development we are in MSG doing, sometimes you only have a release once a year, and with continuous integration and continuous deployment set up, that goes down quite faster because you deploy more often, more frequently. That makes management happy, those numbers, I'm quite sure. And there's also numbers you can sell your project or the project that we did. And there are also numbers that make developers happy. If you have continuous integration set up, it says that the time spent on new features or new work goes significantly up. And the time spent on some unplanned work or repetitive work goes down. So that's, for me, I always want to do something new. I always want to see something that I have not done so far, and I don't want to do stuff that I have to repeat all the time. Okay, so we set up a project in GBP. That's the name of the business unit I work for. It's called CI at GBP. And there were 3 root causes why we set up that project. The first root cause was we had a lot of, or we had some projects, 4 or 5 around, that already were using continuous integration. But each team set up their infrastructure on their own. And they were using all the tools that are there available. We had a GitLab set up, we had some Bitbucket setups, so Atlassian setups, we had Jenkins. So we really tried out each continuous integration tool that's out there. And the problem here is that the infrastructure looked like that. So they went from very poor setup into infrastructure to very good setup infrastructure. So there was no real level. That was one of the root causes why we convinced our management about this project. Another root cause was that we had some project that could do continuous integration but didn't do it because they didn't have the knowledge to set up an infrastructure. Or they didn't have the budget in their project to do something like this. Because there are some costs to set it up. It's not by choice. And the third, and that was the convincing root cause in the end, we have some teams that are switching from R3 development to S4 development to UI5 development, and now they have the possibility. I don't know if you have the possibility in R3 to do continuous integration. I don't think so, or it's very hard to do. So, but now they have the possibility to do it. And because a lot of teams are switching right now, that was then one of those causes why we said we want to set up this project. And what were the 3 goals we set for our project? One was we want to set up an infrastructure for more or less small and medium teams that can use this infrastructure out of the box. Second goal was we want to provide them pipelines with which those teams can start. So they have some about the checks I talked, so about building, running tests, doing some quality stuff. We want to provide our teams pipelines that they can use. If they are fine with the pipeline, okay. If they don't like the pipeline, they can implement some other steps into this pipeline or delete some steps. So, but at least they have a starting point where they can start and don't have to go from scratch. And the third goal of our project was we want to give guidance for the teams who have never touched continuous integration, who do not know what it is and how to use it. And yeah, so these are the 3 goals. And let's see what we did and how we did it. First off, we set up an CI infrastructure. So I just put the tools and the actual tool that we used on that slide. So we are using for source code management, we're using Bitbucket from Atlassian. And we integrate our source code management into our issue tracker or the task board. We use Jira, also from Atlassian here, and that's really an interaction between both of those systems. So that's quite really nice. If you have a task in Jira, you can see all the commits done to that task. You know exactly which code was changed for a special task. And then you can also jump to Bitbucket and look at the code, what exactly was done there, and vice versa. Also, there is a integration into collaboration tools. I just have one here because we use it sparely. We're using Slack here sometimes for collaboration, and there is quite an easy integration into Slack, so that's a collaboration platform, and you can spam your events from Bitbucket into Slack, and then everybody who joined that channel can see what's happening right now in the project. Also, we set up a continuous integration tool. We are using Jenkins here. We're not using Bamboo, because Bamboo would fit into the Atlassian suite, but we have quite some experience with Jenkins, and so we're using Jenkins here. We set up Nexus as a repository manager for the Maven artifacts, for the NPM artifacts and the Docker images, and also for storing our own artifacts. And we set up SonarQube for static code checks. And we're using container technology all over the place here. For setting up the infrastructure, but also it will be on one of the slides later, we also ask every team to use containers wherever it is possible. And let's say you can see that we use Docker here, and really also something I want to say is Docker is a technology every developer is a must-known knowledge. Okay, and that's a bit future this year. We want to develop our continuous integration infrastructure that we set up into a continuous deployment infrastructure, maybe next year. And to set up test systems, to set up integration systems. And we need some container management system that can help us to spin up all those machines. And probably the tool of choice here will be Kubernetes. Okay, so the second goal was pipelines. We want to provide pipelines. So what are we doing here? We are looking at best practices, at new ideas we have. We are looking at teams that already have existing pipelines. We check their pipelines and think, yeah, that's good stuff, that's not good stuff. So we try to get the best things together, put it somewhere, take all the specifics for our CI infrastructure into that pipeline, and then generate some Jenkins files out of it. And right now we are working on 4 Jenkins files, CI pipelines for UI5, and for Angular, for front-end technologies, and for back-end technologies for Spring Boot and for Node.js. Okay, so second part of my talk now is about guidance. I have 10 points here, and I have a slide where all 10 are. So if you want to take a picture, take the picture on the last slide. How do you get a team that is not quite familiar with continuous integration? How do you get them to that step? So first thing is take it slow but steady. So if a team is switching from R3 to S4, you're throwing them under the bus already. They have to learn a lot of new technologies or concepts in S4. They have to learn a new programming language in UI5. They have maybe switched to functional programming from the thing they have done so far. So that's quite an effort for a developer to get from R3 to S4 already. And then I would not suggest to throw the complete continuous integration stuff you are thinking of at them at once. So go step by step and try them to learn what you teach them. And if they have mastered something, then go to the next step. But steady, don't stop. So if you have a goal, then don't stop halfway, but go till the end. Next, teach your team Git. Okay, that looks obvious. Okay. If you give your developers a new tool and you don't teach them how to use the tool, then very strange things can happen. And I have 2 stories with me to share with you. I hope some of you are at least familiar with Git because they are quite technical. So I'm also doing the Git training in our business unit, and I teach the team that was already doing Git for, I think, 2 or 3 months. And then they got the training. And while I did the training, then we realized that they did not know that there are branches in Git, and that they could try something out on a branch and then merge it back to master. And then I asked them, how you try out something? How do you do that? And they came up with a solution, what is branching and merging, but just a different way. So they copied the folder on the hard drive to another folder, They tried their code out on the second folder, then they put all the code back into the first folder, and then they pushed it. So this was branching and merging, but it was branching and merging the old style, like you do it with Subversion or something like this. Yeah. So you see, yeah, they didn't use the tool correct, and the other one is also quite funny, or maybe sad. Depends how you see that. A team approached me and said, Otmar, I think we are not using Git correctly. That cannot be what is intended. And I asked him, what's your problem? Twice a week we get merge conflicts. I say, okay, and then? Yeah, we delete the remote repository, we delete the local repository, then we try to fix the coding, and when we have finished it, we go for git init and then git push again and create a new project. So obviously they did not know how to merge, and so they, twice a week for about 2 hours, they just try to fix their code some way that it works again. Yeah. And this is, well, I really have to say, if you give them tools, learn them the tools. Okay, tip number 3, establish and evolve a Git workflow. Maybe when you start in a project, everybody's just pushing to master. Because you're just trying it out, you're in an innovation phase during your project, and you don't want to think too far ahead. But at some point, you really have to establish a Git workflow. And when I talk about Git workflow, I talk about master, develop branch, some feature branches. I talk about some branches that you cannot push, but only can do a pull or a merge request to. I'm talking about code reviews on that, maybe tool-based code reviews. I'm talking about continuous integration that checks all the things that happen. You have to set that up together with your team. You already have a development process, and now you have to find a Git workflow that fits to your development workflow. And this will not be the end, so your Git workflow will evolve. There are two causes why it evolves. First cause is you didn't set it up correctly at the beginning because you didn't know better. And when you started to use that Git workflow, you see, okay, not working, we have to change something. And the second thing is, it's the timeline of a project. Yeah, you have a project, innovative, then standard development, then first release, oh my God. Then, you have to do hot fixes and maybe other releases. Then you have to think about, how do I handle hot fixes? How do I handle my releases? And then you have to evolve your Git workflow. These are things that you did not have to think about in the first place, but you have to think about somewhere in the timeline of your project. Okay, same is true for the CI pipeline. Also establish one and evolve it. So you don't have to go full-fledged pipeline. You can start with try out the build, so your developers get accustomed for occasionally breaking the pipeline, but still no tests are there. Then you go try all your test sets you have, then static code checks, and really evolve your pipeline. And that's also true because in the beginning, maybe, of your project, you cannot fulfill everything you want to achieve with your pipeline. Let's say code coverage. You're already developing and completely forgot about tests, and now the test coverage never gets to 80% that you are aiming for. So it would not make sense to have a pipeline that's red all the time, that breaks all the time, just because you cannot hit your code coverage. So probably you also have to go for a sprint where you try to develop a lot of tests to get to that coverage. So there is some evolvement there. My next tip is keep your CI pipeline short. So 15 minutes is just something that I say. That's not a rule. This number 5 tip is quite connected with number 6. Why do you want to keep it short? You want to give your developers an early feedback. So they want to have feedback 15 or 20 minutes after they commit it. You don't want to get that feedback on the next day. And what happens if pipelines run longer? So I have seen that. I have worked in a project that had pipelines that ran for an hour or an hour and 30 minutes, then the behavior of the developer changes. Normally, the developer, or depends on the developer, he pushes the code quite often, but if he sees, wow, my pipeline takes 90 minutes and before it starts to run, it has to take a back seat because there are still 4 other jobs that are running already, then they will get a feedback 5 hours after they have committed their code. And so the behavior of the developers change. They only push once a day and probably exactly when they go home, because then they don't have to wait until this pipeline is run. And so they get the feedback on the next day when they come to work. And I don't know what I did 16 hours before. Maybe you do, but I could not react on that. And how do I get short branches? Have different test sets for different branches. On those branches on which you commit quite frequently, probably feature branches, something like this, have just a small test set. That gives you the possibility to go 15 minutes or something like this. Only the tests that you say, these have to be fulfilled, else I will not accept that code. And have more test sets when you go to one of your important branches. So if you go to develop or if you go to master. Here you should really run all the tests that you have. Okay, and one last thing, and I think Marco also said it in the talk before, and I already mentioned it, containerize everything. So use containers in your pipelines. You can run everything on the agent or on the slave that is provided by Jenkins, but you will probably share that worker with some other pipelines, and then there can be some bad interactions. So it's better to have your pipeline running in a container agent, and then you will never experience that. Also, what I also suggest is often when running tests, you see that people set up databases somewhere where they can use it. Also, I think that's a problem because more or less more builds will try to access that database. Maybe that they can interact with each other and do something that's not supposed to happen. So I suggest also for something like database, spin up a Docker container during your pipeline, do the tests against that database that is in the container, then shut it down again. Okay, and after we have tackled 7 points, which were about processes and tools, there is one pillar of DevOps still left, and these are the people. You can have that set up, and it's working super, but if your developers don't like what they see and do not want to participate, then it will fail badly. So the next 3 points are about your team. First, create an awareness for collective code ownership. So everybody should know that not only the one who made the mistake can fix the mistake. So it's the whole team that is responsible for the code. And if your coworker already has gone home and broke the build, then someone else also can fix it. So you have a collective code ownership of your code. Another point, fix broken builds immediately. Okay, that's something you read everywhere. But we encountered it as well, and it's really, really important. But what happens if you don't fix them? Okay, the build is broken. Okay, so the next one also commits to that. It's still broken because there is an error in there. The next commits, the next commits. So at the time when you try to fix it, you don't only have to look at that one commit that broke it, but you also have to look at all the commits in the meantime and find out, is there not only some problem in the first commit, but also problems in the later commits. And that makes it way harder to fix those builds. Also, if people look at their CI dashboard and see their pipeline is read all the time, they will lose the faith in continuous integration. They say, why are we doing it? It's read all the time. I just push my stuff and go away with that continuous integration. So fix it immediately. And my last tip is try to visualize your build states somehow. I have seen it in 2 teams, how they do it. One team is throwing their CI dashboard, or their Jenkins dashboard, with a beamer at the wall in their room. So everybody can make a look and see, okay, it's red, I can push. Or, oh, it's green, I can push. Or, oh, it's red, I should not push. Maybe I fix it before I push my code. That's quite good, and also that puts the team together if they are able to have a working pipeline all the time. And another team I saw, they are using Slack as their dashboard, so they push all the important information into their collaboration tool, and everybody who is on that channel can see what's going on right now. Okay, so I'm already at the point there I will close out my talk. So if you are a member of MSG, maybe in GWP, and you want to do something with continuous integration, just write me an email and we'll see if we can do something for you. But maybe you're on the waiting list right now. Yeah? Okay, so that's it. With my talk about what we have done so far in GWP about continuous integration. Thanks for your patience, especially about the hardware problems. And do you have any questions?
What you are describing, it sounds like you need some... Yeah, okay. So what you've been describing, evolving your pipeline and stuff like that, it sounds like you need know-how to do that.
Yeah, sure.
How would you propose that you bring that know-how into the team? How do you have a role for that, or?
No, not really. So we are helping each team that wants to go on our infrastructure. We guide them. We also help them write their pipeline, but it should not be our work only. So maybe we take 1 or 2 team members with us and show them how to write a pipeline, and then they can take over. But yeah, that's how we plan to do it, or how we are doing it.
Should everyone know to write a pipeline in a team, or is it?
It would be perfect, but at least more than one. Yeah, it should not be exclusively the job of one person in a team. You don't want that in an agile team. Normally, you want to spread out your knowledge there, and because that one is then responsible for everything, and you know the problems that happen then.
More questions? And thanks, Otmar.
Thank you.